All right, let's go ahead and get started. So again, hello everybody, and welcome to today's webinar presentation titled DevOps 101 CI/CD, brought to you by JFrog. I would like to introduce you to our presenter today, Kat Cosgrove. Kat is a developer advocate at JFrog and an actual cyborg. Her professional background has run the gamut from bartender to video store clerk to teacher to software developer. She credits this wide-ranging experience for her success as a speaker, developer, and advocate. Her specialty is approaching 101 level content for junior developers or anyone else who considers themselves a newbie, with a particular focus on DevOps. When she's not building demos or at a conference, she spends her time playing video games, watching horror movies, and reading science fiction. She lives in Seattle with her cat Espresso, who is the real brains behind the operation and actually ghostwrites all of her tweets. I'd like to do a quick sound check for Kat. So Kat, please say hello to our audience, and audience, let me know if you can hear her.
Hello, audience. Can you hear me?
And it looks like we're good to go, Kat, and I'd like to pass it off to you for the presentation.
Okay, sweet. Here we go. Hey, y'all. Thanks for coming to see me, and welcome to DevOps 101 CI/CD through the ages. First, a little bit about me. Some of this has already been covered by DZone, but my name is Kat Cosgrove, and that is Espresso. I'm a developer advocate for JFrog. Before that, though, I was actually an engineer here on the IoT team. And I didn't exactly get where I am through like strictly traditional means. Um, like she said, I have had a lot of different weird jobs in my life so far. And I did go to college, but I didn't go to college for computer science. And also, I dropped out pretty quickly, actually. A lot of my success as both an engineer and as a developer advocate, I credit to the way I got where I am, like not getting here through an exactly traditional way, because it's allowed me to see the tech industry from a lot of different angles and have a lot of different kinds of struggles. But some of these struggles are fairly universal, regardless of how you get here, and they're also not really being addressed. I give talks like this to try to solve that. If you would like to get a hold of me later, that's pretty easy to do. You can find me on Twitter at Dixie3Flatline, and I'm always happy to help if it's within my power. So please don't hesitate to reach out if you need something, though I will be taking questions at the end. If I miss your question or if you come up with something later, just, you know, shoot me a DM and I will get back to you. Also, my slides will be up after this presentation at jfrog.com/show notes if you want to see them. First, let's level set a little bit. We have a lot of jargon in cloud technology and specifically a lot of it in DevOps. Some of these concepts are relatively new and the definitions kind of do change over time. So I'm going to start by talking about what DevOps actually is. And like, is this a methodology? Is it a tool set? Is it just buzzwords? Or is this stuff that's actually going to make my life easier? A lot of the documentation we have out there assumes that you already have some context or that you're proficient in some related tooling, and that doesn't really make it easy to learn. So let's take a look. I'm going to talk about CI/CD. The CI stands for continuous integration, and the CD can stand for either continuous delivery or continuous deployment. They do mean different things. I don't like that about the term, but I promise I will explain. Continuous integration means merging all developers' working code base with the source multiple times a day. Doing this requires a series of automated build and unit tests to ensure that none of the proposed changes cause problems, but the result is that bugs and integration issues get discovered much earlier in the development process. Ideally, a build is triggered with every single commit so that failures can be caught immediately and corrected. This also forces engineers to write code that is more modular, which makes it easier to support later on, because like ultimately humans are going to be looking at your code and extending and maintaining your code. So it does matter. Continuous integration has actually been around for a long time. It's been a thing since the early 90s. It hasn't always been called that, and some of the implementation has changed, but the spirit has remained the same. Merge changes into source in smaller but more frequent increments, test that the project still builds and runs with those changes, and make sure your engineers are all working from the most recent version of the source. If you do this, you won't end up with a ton of merge conflicts or surprise problems when it comes time to build. This was first proposed by a man named Grady Booch in 1991 in his book Object-Oriented Analysis and Design with Applications. The Booch method advocated for more frequent use of classes and objects in programming in order to simplify design. His version of continuous integration didn't suggest releasing multiple times a day, though. In 1997, extreme programming became a thing, and it built on the Booch method by advocating for releasing multiple times a day. This kind of changed the game, honestly, and I know that the name sounds ridiculous now. It gives me big, like, 90s product marketing vibes, but it didn't mean extreme in like an X Games, MTV kind of way. It meant taking concepts and paradigms that were already accepted parts of writing and releasing software and then taking them way further, like to the extreme. So thanks to extreme programming, we now have shorter release cycles, pair programming instead of just code review, unit testing, and acceptance testing as standard aspects of writing software. These are all things that make our lives easier and radically improve quality. More and more methodologies went from there and built on the work of their predecessors, from Scrum to Kanban, all with one goal in mind: make it easier to write clearer, higher quality code and get it out to the users faster. In the early days, while we recognized that we needed to be releasing more frequently, we didn't really have tools to make that happen, actually. We were doing it manually, and it kind of sucked. We didn't get the first open source tool to make continuous integration easier to achieve until 2001 with the release of cruise control. It looks pretty primitive now, but at the time it was revolutionary. And this is not the actual logo for cruise control. I just couldn't find a version of their logo with a transparent background because the PNG image format was not widely supported by browsers until Internet Explorer 9, which was released in 2011, one entire year after the last update to cruise control. That's how old it is, and for some reason people actually are still using this. Just a heads up, it has not been touched in quite a long time, but it is still in use. Anyway, cruise control was revolutionary at the time of its release. For the first time, we had a system we could install and stand up ourselves to automate the management of builds, which allowed us to release way more builds. It even integrated with your IDE if you were using Eclipse, at least. Cruise control was Java specific, though. If you were writing, say, like Ruby or something, you had to use the Ruby variant of cruise control, and there were a few different variants of it. Eventually, cruise control was overtaken by Jenkins, which is still widely in use today. Jenkins supports a ton of different languages. It can be made to do almost anything you want, and it has an enormous community around it so that when you do run into difficulties, it's almost certainly been documented by someone else before. It's stable, it's secure, and it's popular. However, Jenkins is starting to show its age here. You have to stand up infrastructure and install it yourself, and someone has to be responsible for maintaining it. This is true to an extent even with Jenkins X, their newer cloud native offering. There are managed, oops, there's my VPN yelling at me. There are some like managed Jenkins services you can buy, though. You don't actually like fully have to do this yourself anymore, but it is still the default way. Enter the cloud, though. Rapidly self-hosted Self-managed CI tools like Jenkins and the now defunct Cruise Control are being replaced by cloud services that you don't have to babysit, like Travis CI, Circle CI, GitHub Actions, and JFrog's own pipelines. These things support dozens of different languages and build environments. They know how to deal with cloud-native technologies like Docker and Kubernetes. They integrate directly with a wealth of other services to handle deployment or analytics or observability. It's both more flexible and lower maintenance, but you do lose some security by not being 100% in control of your CI system. For most people, this is an acceptable trade-off. That's just CI though. We still have to talk about CD. Continuous delivery means what it says on the box. Your software updates are continuously delivered. In concert with continuous integration, this means you should have the ability to deploy a new build very, very rapidly because you've already automated some quality gates that would otherwise need to be performed manually, like building and testing. That reduction in manual labor means you get to release a bunch of small changes rather than one huge update every couple of months. And since you're also now making smaller incremental changes, you can be more confident that your release isn't going to break when you deploy to your users. Continuous deployment, the other interpretation of CD, is similar, but it goes one step further in that the deployment step is automated too. In continuous delivery, you still have a manual quality gate involved before an update is out in the wild, and automating this away is a controversial step for some people. It does require a lot of trust in your system and in your tests, but personally, I am a really big fan of it because, like, for you to be as efficient as possible, for your DevOps pipeline to be as efficient as possible, we have to remove human involvement wherever we can. I say this a lot, like easily in 40% of talks I give, but humans are actually pretty bad at repetitive tasks. There's like a hard limit to how good we can get at something by doing it over and over and over again, because like we get bored or we get distracted or we have a bad day and we're actually pretty slow. So write good, comprehensive tests and automate everything you can. Then accept that you absolutely are going to deploy a bad update eventually, whether a human is involved in clicking the big green button or not. You pressing the deploy button does not reduce the risk of breaking prod. It really just does not. What matters is how quickly you can respond to and correct a bad update. Both continuous delivery and continuous deployment help you get there. But personally, I automate the deploy too. So high level, CI/CD is just the term for the marriage of these two concepts, and it's an important part of DevOps since automation and efficiency is what we're all about here. And one doesn't really work in the concept of DevOps without the other. Implementing CI/CD practices gets you a faster, more reliable release cycle. You can add new features or bug fixes much faster since you know your engineers are all working from the most recent source. You know there are unit and integration tests, and you know it builds. There aren't a bunch of manual steps involved anymore for like the engineers or QA or whoever else you might have managing quality gates. Instead, somebody pushes code or opens a pull request, and those things are taken care of by your CI/CD tools. But how does it actually work? To start, you need a CI/CD tool. This is what's going to automate a bunch of manual processes for you. It does take some time to set these up at the start of a new project, but personally, I am the flavor of lazy where I am willing to do like a bunch of extra work at the beginning to make sure that I don't have to do a bunch of repetitive tasks later on. The specifics of configuring any of these tools does kind of vary, so you'll have to check the documentation for your chosen tool, but broadly, they all work the same way. You set something as a trigger, like telling it to watch your source repository for a commit or a merge. You then configure a series of steps, each with pass-fail conditions, like telling it how to run your unit tests, how to build and in what environment, how to scan for vulnerabilities, what to do with the results of that scan, or how to deploy your application. With a sufficiently detailed CI/CD pipeline, you really don't have to do anything other than write code and then push it at that point. It's going to handle everything else for you. Usually this is done by defining it in some kind of configuration file, usually in a format called YAML. There's like a long running joke that is, I'm convinced, never going to go away, that DevOps is just YAML, and you may as well call SREs and DevOps people YAML engineers, which is becoming tired as a joke, but it's also like super true. You know, most of these tools do also have like a web interface that allows you to get a nice graphical overview of what your steps look like with logging output, so you know exactly what is going on and when. It's pretty great. So now we know what CI/CD is. So here's what goes into a good update or a bad one and why it's important. If you are around my age or older, I'm 31, you probably remember how much drama used to be involved in software updates. They were really large, they were infrequent, they took a lot of time to apply, the changelogs were huge, and there was a fairly significant chance that the new version would be buggy in some way. It was just generally a really inconvenient experience. If you are younger than me, it might sound kind of wild now, but it used to be totally normal and expected to go like a year without seeing a software update for some application. I don't miss that, but it definitely used to be common. You could go longer, honestly. Regardless of your age, can you imagine waiting that long for a software update today for most applications? Like, I assume that some of you, maybe even most of you, are working developers today. Can you imagine waiting that long to release? I can't. I cannot imagine doing that anymore. In a lot of situations, it wasn't even possible to just download an update. The manufacturer would have to provide you with the update via physical media, whether that meant floppy disks or CD-ROMs or a USB drive. The last time I had to do that was actually fairly recently. It was 2009, and I was updating the software that the video store I worked at relied on to operate. Like literally in 2009, the vendor had to snail mail me a thumb drive. They would not just email me the executable. I did try, they refused to do it. And to be fair, this particular application was a bit very behind the times. Really, it still required a machine with a serial port, which by then was not a super common thing to see on a workstation, since license authentication for this application was performed by verifying the presence of a physical dongle that only connected via serial. I can't imagine having to deal with that for most applications today. Some things do still work this way, but it's exceedingly rare outside of a handful of industries, and it is typically like an extreme security situation. Phones have suffered similar problems with the CD side of things. Way back in the 90s, there wasn't really a way to update software to get like Snake on your phone or whatever. You had to buy a new phone. Eventually, phones did get smarter, but updates still require plugging the phone in, and cloud storage wasn't really ubiquitous yet. So data transfers when you upgrade to a new phone were done via a physical cable. The last time I had to do that was when I switched from a Samsung Galaxy to a Google Pixel, which was like maybe 5 years ago now. And now it's something that we don't even think about, you know? You switch phones, all your contacts and photos and apps and whatever else are just there on the new phone. There's some setup time, sure, but it happens pretty seamlessly. And you don't notice it when an app updates on your phone anymore. It probably just happens while you're asleep. I think the first time I noticed that my phone was not asking for permission to update some applications was about 2 or 3 years ago, and these changes are all because of CI/CD. This is what CI/CD gave us. We've gotten much better at this over time, and a lot of it you can credit also to the prevalence of cloud computing, but we are still not perfect. So here are some real world situations where CI/CD could have prevented an actual tragedy. We'll start with the money angle. It turns out that not updating frequently and automatically can actually be really, really expensive, sometimes fatally so. In 2012, a bad software update caused a major stock market disruption and tanked the value of a company called Knight Capital. They were a trading firm that specialized in automated transactions on the New York Stock Exchange, and one day it all kind of fell apart. See, they weren't automating their updates or their deployments, and they weren't updating on a regular basis either. Humans, again, are bad at repetitive tasks. We're especially bad at them when we don't get any practice at those repetitive tasks. You've got to, do something on a semi-regular basis or you're going to be anxious every time. So, two things contributed to this disaster. When the engineer was updating the 8 servers responsible for handling these automated trades, he forgot one. Only 7 of the 8 had the new software. They also reused an API endpoint and changed the behavior in the new version. You can probably see where this is headed. When it went into production, it was chaos. Requests to the old server running the old API endpoint wreaked havoc on the share prices of 148 companies. Engineers responded by taking the 7 updated machines offline to roll back the software, increasing the load on the one machine that was never updated to begin with. There was no logging, there was no monitoring, and no alerts. They had to sit there desperately trying to figure out what had happened, losing money the whole time. In the 45 minutes this bad update was live, Knight Capital lost $440 million and ultimately went out of business as a result. This was preventable. Those servers were all being updated manually, but remember, humans get tired and we get bored and we get distracted and we have bad days. It's normal, and I really feel for this engineer. It was not his fault that this happened. He shouldn't have been put in a position where this could happen. If the processes had been automated, he wouldn't have been there. But for me, the most compelling argument in favor of spending the time and effort on CI/CD is security. CI/CD enables you to update your software much more quickly, which translates to being less vulnerable to known issues and being able to react more quickly if a breach occurs. This is a story most of you are probably familiar with, but you might not be aware of the cause and just how ridiculous it was. In September of 2017, EQUIFAX announced that a serious breach had occurred between May and July of that year. Remember that first month, May. The names, addresses, birth dates, driver's license numbers, and social security numbers of just short of 149 million people had been stolen. The hackers had exploited CVE 2017-5638, which was a vulnerability in a very commonly used web framework called Apache Struts. Going into detail about like how that exploit actually works is kind of out of scope here, but the gist is that it allowed an attacker to remotely execute commands with whatever authority the web server had. And this was not a vulnerability that flew under the radar, to be clear. Even before the breach, this CVE was pretty big news in the security world. Anything that allows remote code execution is really serious. It has to immediately be taken seriously. It was assigned a CVSS score of 10, which is as serious as you can get. That translates to find any incidents of this in your systems immediately and upgrade to the fixed version, because you absolutely, your whole system will get pwned. The vulnerability was disclosed and published in March, months before Equifax would even be breached. They should have known that it existed. Once they discovered that breach, it took them 2 entire months to find and upgrade all usages of the vulnerable version of struts. Lawsuits were filed, obviously, resulting in a $575 million settlement with the FTC, as well as payments and credit monitoring for those affected. But unfortunately for us, the number of people affected by the breach was so large that after attorney's fees, most people got nothing but a lifetime of being paranoid about their credit. There were a number of things that could have prevented this from being a disaster here. It's not just a CI/CD issue in this case, but that definitely contributed. Vulnerability detection tools like JFrog X-Ray or something similar, they don't tell you about vulnerabilities that haven't been publicly disclosed yet, but they do tell you about vulnerabilities in your code that have a CVE. If it exists in the NVD, the National Vulnerability Database, tools like X-Ray will tell you. Tools like Artifactory know what is in all of your packages. They know what software you're depending on. And CI/CD tools let you update these things more quickly. So if they had been using some kind of binary repository manager, if they had had some kind of vulnerability detection in place, they would have known that they were vulnerable to the struts CVE. They would have known specifically which packages and dependencies contained that particular version of struts. They would have known which version to change it to get around the fix. And if they'd had something like CI/CD, like JFrog pipelines or whatever, they would have been able to roll out that fix quickly. Like, it shouldn't have taken 2 months to repair this. Ultimately, the hackers spent something like 140 days completely undetected in Equifax's systems. That is absurd, you know? And this was a major disaster that is going to haunt a lot of people for the rest of their lives because they couldn't update quickly. They couldn't tell when something was wrong. So to wrap things up, CI/CD is a combination of methodology and tooling. It is not just tools. We say this a lot in DevOps, but DevOps is a culture, not a tool set, with the ultimate goal of increasing your speed and efficiency as a developer by automating tasks like building, testing, and deploying so that you can do all of these things more often so that you're happier and you're less stressed out, and so are your users. The benefit to you is more frequent software releases, earlier detection of bugs, and bad releases making it to production less often. It's been around for a long time, longer than we like to think, and I think it's really important to give this kind of historical context to tools that seem really, really complex, because it can be hard to grasp a new tool without understanding the why, and you don't understand the why if you don't know the history of how we got here. And CI/CD has changed a lot over time. We've come a really, really, really long way since Booch first proposed it as a concept in like 1991. And it's going to keep going interesting places and making us do things faster and do things better and release cooler software that keeps our users happier and keeps us out of trouble with our legal departments in case things go wrong. Anyway, I hope I've helped you understand what CI/CD is and why you might want to do something like this. Feel free to get in touch with me on Twitter at Dixie3Flatline. You can also shoot me an email at catc@jfrog.com, but I will warn you that I am not great about replying to emails with any level of urgency. It is a pandemic. I get a lot of emails. And if you've got any questions, I'll take them now. Just throw them in the chat box or question box thing. I run a small company and am looking for a YAML engineer. Yeah, the term YAML engineer is very funny for me personally. Let's see. Can here. Hello. Is CI/CD the most important historical development towards DevOps? I am not sure. I think I would actually argue that the invention of the package manager is more important than anything else. Before we had package managers, it was considerably more complicated to do some of this stuff. We didn't really have the ability to make it simple to install or upgrade anything because we didn't have dependencies packaged with anything. So I think the package manager is more important, but CI/CD is more complicated to explain. Can you please elaborate more on how CI/CD stands in the DevOps process? Is it possible to have such process without it? I don't think it's possible to have DevOps without CI/CD. No, because like ultimately the goal of DevOps is to make it faster to deliver software updates. And CI/CD is one of the most important parts of doing that. It isn't possible to automate things like building and testing and deployment without a tool to do that for you. So I think it's like absolutely a requirement to have CI/CD. Is there a service or container to bring security into a pipeline, or do they still need to be written one at a time? If you mean like vulnerability detection by security, yes, there are tools that do that. JFrog X-Ray does that. If you are also using Artifactory, and it can look into Docker images as well. Like you can peel it apart layer by layer and look at your dependencies in there. You can automate things like if X-Ray finds a vulnerability with a CVSS score of 10, it automatically fails the build, blocks downloads, and sends an email to everyone under the sun with the big red warning letters. Or you can just, have it do a little bit less. It doesn't have to be that aggressive, but yeah, there are tools you can use to help with this. Is CI/CD going to replace any other processes in the future? Well, at this point, CI/CD tools are so advanced that like if you can shell script it, like if you can script it with Bash, you can run it inside of a CI/CD system. So it's already doing quite a lot at this point. We've started getting into like config management and GitOps as well too, and those kind of like those go along nicely with CI/CD, but they're not part of CI/CD. Let's see. Any book recommendations for this topic? Yeah, I would say Liquid Software was written by my boss, actually, Baruch Sadegurski, and the CTO and one of the founders of the company I work for. And there's also DevOps for Dummies, which is by Emily Freeman. That goes into CI/CD quite a lot too, and is a good starter point. What does JFrog's recommended CI/CD pipelines look like? So JFrog pipelines is built into the JFrog platform, which actually does have like a free cloud tier. So you can go play with it yourself. And we do provide like, if you look in our GitHub repo, there's a starter pipeline, like sample YAML you can use to just like fire it off immediately. But it is YAML, which is very easily human readable, also easy to version. Pipelines natively integrates with a bunch of different tools, but it does integrate with like things like Bitbucket and GitHub and GitLab and Azure DevOps and on and on and on. So you can plug it into virtually anything. It's pretty cool. And like I said, the JFrog platform has a free cloud tier. So you can actually just like go use all of our products for like your personal projects, and it's just there. It's pretty rad. Let's see what else we got here. Does it support any clouds, local Kubernetes? Like CI/CD in general, I don't think typically you would run Kubernetes inside of your CI/CD system, but like, yes, there are cloud native solutions for CI/CD. JFrog pipelines is one. I build Docker images inside of my CI pipeline all the time. It's just a normal thing. So yeah, it's pretty common for me to write a pipeline that builds my Docker containers inside of the pipeline, tests them, and then automates deployment to like some hosted Kubernetes service on a cloud provider. You can integrate JFrog pipelines directly with those cloud providers, so it's pretty simple to do. Which CI pipeline does JFrog work with? So pipelines is a CI/CD tool by itself, but if you wanted to use JFrog Artifactory with another CI tool, that's totally doable. We have a CLI, and it's pretty common for me to use GitHub Actions for a demo. Like if I am doing a hands-on workshop teaching somebody how to do CI/CD, then yeah, I will often use GitHub Actions for that, because there is just like a GitHub integration in Artifactory, and then I use the JFrog CLI inside of my GitHub Actions workflow to like connect to my Artifactory server, which is like somewhere on an AWS server, and then build my containers, tag them, push them to my cloud Artifactory, and any build info about them, etc. So there's an integration for like everything. Haha, no, I run CI/CD on Kubernetes on AWS, not running it locally though on Minikube or Kind. That would be cool. That would be fun. I will try it. I use Minikube a lot for demos when I teach like an intro to Kubernetes hands-on workshop. I always use Minikube just because it's, you never see it in production, but it's free and anybody can install it, and it uses a bunch of different things. So it's pretty rad. What do we got? Thanks for your time. You're welcome. Happy to help. What about JFrog in comparison with fully free analogs? If you mean our CI/CD tool or Artifactory, the difference, even the fully free alternatives I wouldn't really call them analogs. The only fully free is, or at least that I use on a semi-regular basis and see in the wild a lot, is Jenkins, which requires you to stand up the server and babysit it yourself, right? Tools like Travis CI and Circle CI do have free tiers, but they are freemium. There is a point where you have to pay them. So I wouldn't really call them analogs, and they have different strengths. Pipelines is good because it integrates directly with Artifactory. So if you're already using Artifactory, using pipelines just makes sense. It's already there. It's in the same pane of glass. You don't have to worry about like setting up integrations or plugins. It just kind of goes, which is good. But if you don't want to mess with learning a new CI tool, like you can still just use it with Circle CI or Travis or Jenkins or whatever. You just may have to set up a plugin, or you have to use the JFrog CLI. So it's just kind of a matter of like, what do you want? What do you like? The everything is together in one pane of glass thing is really popular with like enterprise folks, like enterprise applications. Big businesses like to have a lot of control over all of the tools they use, and this lets them keep it like all in-house. So it's kind of just a different thing. X-Ray and GitLab. I don't think that X-Ray and GitLab can work together like that. So X-Ray, in order to work, it needs to have access like to your compiled binaries, to your build artifacts, and it looks at Artifactory for those, not at GitLab. It doesn't look at your source code. It's looking at your like actual build artifacts when it does that. You said that Minikube is cool to work with. What if I decide to use K3s or Flex or GitLab CI/CD? Is this a good choice? So Kubernetes is not a CI/CD tool. K3s is also not a CI/CD tool. It's just, you know, it's a container orchestration tool. I really like K3s though. K3s is actually how I learned Kubernetes, which is not the not the easiest way to learn how to use Kubernetes. But K3s has its strengths and it has its weaknesses. You know, it is built to run on very small, like low resource embedded Linux devices. And it does abstract away some of the more complicated parts of running Kubernetes, like generating TLS certificates and whatnot. But because it is abstracting some things away, it doesn't feel as full featured, and some things can be a little bit wonkier to use. Minikube is the like closest analog to like real whole roll your own Kubernetes. As for GitLab CI/CD, honestly, I have to say I have never used it, so I can't specifically comment on GitLab CI/CD. If we have already running application in a monolithic architecture, then when should we start from? No test case written, where to start? That's a hard thing to unravel. You do probably need to unravel it at some point. Having a monolith is not, that doesn't mean you can't have CI/CD. You can have CI/CD and have your application be a monolith. I don't actually think that microservices are the end all be all. I don't think that everything needs to be microservices. Some things are better as a monolith, but you can still do DevOps or do things in a more DevOps way and have a monolith. So, but you do need tests. You really need automated tests. So that's something that's a little bit harder to unravel, and you unfortunately probably need to like hire an expert to help you unravel that if that's something that you want to do. It's something that I would recommend you do if there's not already a qualified person there capable of doing it. Yeah, you've got to hire somebody to take a look at it. I think that's about it. Does anybody else have any questions?
It looks like those are all the questions I'm seeing, Kat.
Okay, then I will toss it back to DZone.
Awesome. Thank you so much, Kat, for that intro to DevOps CI/CD presentation. DZone would like to thank you so much. DZone also would like to thank JFrog for providing that audience with a phenomenal webinar. Lastly, thank you to all of our attendees today. We hope you learned something new that will help you in your developer career, and we hope you have a great day.